Alright, so Unit 5 we looked at radical and rational functions. Basically we figured out how to draw radical functions, we looked at how to transform radical functions, and then we also looked at just the domain and range of rational functions. So we're going to try and get through as much as we can before that bell rings on us. So sketch the graph of the radical function of f of x. Basically what we want to look at is the rules on how to draw a radical function. So let's go through that first. Can we take square roots of negative numbers?
No.
No. So that means anything below the x-axis cancelled out. So if f of x is less than 0, then the graph of y equals the square root of f of x does not exist. In other words, anything below the x-axis, eliminate. Okay, the reason why I put that first bit though is because what if they gave a question like, which statement is true or false about this graph? You would have to know the language, okay? If the original graph is below 0, in other words, below the x-axis, then the radical function does not exist. So let's do step by step. Anything below the x-axis, let's cross out. It's not going to exist. Invariant points. Okay, invariant points will exist at your x-intercepts and when y is equal to 1. I'll just explain that a little bit further with the point mapping. All points will be mapped to x and the square root of y. So if I took, say, 4, 0, and I had to square root that 0, what's the square root of 0? 0. And x stayed the same, right? So you don't have to write this down, let's just do a couple examples. Okay, the square root of 0 is just 0. So is that an invariant point?
Yes.
Yes. Now what if y was a 1? Square root of 1 is 1. So basically that's why we have invariant points on x-intercepts and y equals 1. Okay, feel free to write that down or just do the point mapping. Okay, so x-intercepts, invariant, invariant, invariant. Sorry, this scale is so bad. Okay, let's just put 1 here. Okay, invariant, 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 invariant. We have lots of invariant points on this graph. Okay, we also talked about point mapping. xy goes to x squared of y. So when y is at 9, when we take the square root of it, it's going to be down at 3. So like I said, sorry, the scale is so poor. Okay, all of these points will go down here. And then this is in line with the 4. So when you take the square root of 4, they all go to 2. That's a 2, now a 3. Again, I'm sorry about this graph. Now, if y is greater than 1, okay, where does the original graph exist then? Below f of x. Why does it exist below? Well, when you take the square root of 9, it's 3. So it's going to exist below it. The new graph is below the original graph. Okay, when y is between 1 and 0, then the radical function f of x is above. the original graph f of x. So let's just draw this now. Variant points. Okay, when we're between 0 and 1, are we above or below? Above, 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 above. Now pretend that this original graph just went that way. My skills on drawing art or whatever, my word, whatever, drawing on Word is kind of limited, so sorry if it was a bad graph. Okay, if it's above 1, then we draw below. We're below, and we're below. So now we've drawn our new graph. So I might just skip stating the domain and range of the original graph. Let's just state the domain and range of the new graph. Okay, so domain. I'm just going to put a few points here. Okay, what's the domain of this graph, this new radical function? Okay, it goes from -2, it touches at -5 and then keeps going. Is there any breaks from here to here? Or here? No, it's continuous. So x will be less than or equal to -2. Okay, what about on this side? X will be greater than or equal to +3. So I could just write it in one string. You could have written it the other way as well. Okay, x is less than or equal to x, or greater than or equal to 3. Doesn't matter. Means the same thing. Charney, how are you doing?
Good.
Is it the notation or just looking at the graph?
Wait a minute. So, wouldn't it be negative? It's less than or equal to -2, and then greater than or equal to -5.
Oh, what's this value? I had just assumed it was 3. Maybe we'll, sorry about that. We don't have a value on the x-axis here, right? I didn't put a
Yeah.
scale. It probably would be like a 1, right?
Yeah.
Sorry, let's change that to a 1. 3 was a bit excessive.
Wait, but wouldn't it be because it can't, it doesn't exist like on the x-axis there, like.
In between here?
Yeah.
Nothing exists on the new graph here,
Yeah.
because it was wiped out.
Oh, are those like restrictions then?
These?
Yeah.
So this is where the graph exists. See this blue graph here?
Yeah.
Okay, anything greater than or equal to 1 is part of the graph.
Oh, okay. Yeah. I
And then
see.
anything less than or equal to -2 is part of the graph.
Okay. Yeah. Sorry. I just kind of got confused.
Does it make sense
Yeah,
now,
no, it
though?
does, yeah.
Okay? Anytime you need to stop, let me know. That's what
Okay.
this is for. Alright, now the range. Okay, is this going forever and ever and ever and ever, ever?
Yeah.
Yeah. And over here it's going to go forever and ever and ever and ever. So y will be greater than or equal to 0 because it goes from the x-axis up. There's nothing below the x-axis.
I'm just looking at the, so x is less than equal to
You-
-2.
Yeah, always read from the variable. X is less than or equal to -2. X is greater than or equal to 1.
Okay, where do we have
It
the
kinda-
George for?
Um, My apologies if you missed that. I just looked at the 3, but on the x-axis, let's just label this a 1 because there wasn't a scale given. Okay, and it looks like it's probably a 1. If that's 2 spaces over, and that's 1 space over. So x is greater than or equal to 1. X is less than or equal to -2. Yeah.
So we're just kind of saying that, you know how it kind of goes below the x-axis at -5 there, we're just kind of going like, it doesn't
We're
really
just
matter.
saying, yeah.
'Cause-
Yeah, technically there'd probably be 2 x-intercepts here, but like I
Yeah.
said, my graph is
Yeah.
so poor, the one I drew. So if you get this on a test, guaranteed you're gonna have a way more accurate graph to look at. So
Yeah.
I apologize for the inconsistency. That probably wouldn't exist there if you had an x-intercept
Yeah.
right there. Okay. in order for it to dip below the x-axis, it'd have to be not tangent, there'd have to be two x-intercepts,
Yeah.
which means there'd be like a fraction of a gap,
Yeah.
but we're gonna pretend this wasn't there. Thanks for looking so specifically though, because those are the details you will have to look at.
Yeah.
Do you guys want to practice drawing another one? Or do you think we have the rules down?
Yeah.
Okay, moving on. You're gonna have to solve equations. Now, algebraically, you guys were tested on this quite a bit in Math 20. But in Math 30, you're mostly just looking graphically. Okay, so there's two different methods. You can use the x-intercept method and the x-intercept method. Okay, let's just pick one. Let's do the intersection method. Okay, so intersection method. y1, that's going to be the left-hand side, square root of 2x plus 1. And y2, I'm going to let be x minus 5. So when you graph it, you get something like this. Our solution is that intersection point. So let's go ahead and put that in. I'm going to change my window setting. Alright, so I can see where it's crossing each other, so I can just solve now. Second, trace, number 5 for intersect. Move it over to that intersection point. And we're sitting at 9.5, and that would be our solution. So you get 9.464, etc., etc. Okay, if I use my x-intercept method, okay, y1 would look like the square root of 2x plus 1 minus x plus 5. What are we solving for? X-intercepts. I don't think I need to review how to find x-intercepts at this point. So to keep flowing, I'm going to move on. Is that okay?
You have 2 minutes.
Okay.
So we call it a day. Is this a good day?